Welcome back to class, dear students. In this lesson, I am going to take you through what are the differences between the Solang Solidity and vanilla Solidity or native Solidity. So we'll check it together. We try to learn. This is a very important section because, like I've told you in the previous one, you cannot just take vanilla or native Solidity and just take it and just load it up on Solana, because the account on Solana is different from our account. How smart contract is managed on Solana is different. So we'll learn all those things together in this lesson. And anytime you get stuck, you need support, reach out to the community. I'll be there. My AI and other team member as well will be there to support you. So make sure you always know you have people. At least we are all learning together, and it's not that I'm a master of all this, but at least to the level I'm always here to support. So let's check the differences out. Yeah, like I said, we'll look at the end of this lesson. You should be able to identify and understand the key difference between Solang Solidity for Solana and vanilla Solidity for Ethereum. Like I've told you, Solang Solidity is just like a flavor of Solidity. It's still purely Solidity programming language, adhere to a lot of things and even try to be as compatible as possible. So just start something because of the blockchain is targeting, because like I've told you, Solana isn't building EVM compatibility. Solana is what Solana is. Then Solang help to just make things compatible for Solidity on it. So now let's check the comparison one after the other. In terms of account structure, Solidity on Solana utilize two accounts, a data account and a program account. So that's why any resources or things like that, you always check out our blog and things like that on the Programming University, or when we share in the Discord or to the community. So we have some resources that could help you learn more about this. I think in the previous lesson of this, I should link it up as well. So this account structure demand two things. You need two account structure for it to work. You have the account structure that is for the executable program on its own, and you have the one that is for the non-executable. But on Ethereum, it's just a single smart contract, as the data, as the bytecode, everything together. But on Ethereum, so on Solana, so that's why when you are now developing, you need to split your smart contract into two, the storage separate, the smart contract code separate. So that's why you cannot just copy from Ethereum and then paste it on Solana. Another thing different in there is the contract upgrade. And when you look at it based on the account structure, like I've explained, one need two accounts. One just only hold the code, and the second one hold the data. You understand? But you will need to, when you want to upgrade, the Solana makes it super easier, because since the code is alone, different from the data you stored with the smart contract, you can easily upgrade the code as long as it easily just adhere to the data. You understand? So compared to Ethereum that has both, you don't want to lose the data, and so you need to implement a lot of a bit complicated upgrades, you understand, to be able to do that, which is usually for advanced Solidity developer. But this Solana makes it much easier. Then the next one, data type. When the Solidity on Solana uses 64-bit integer and 32-byte address. So like what I was saying before, to give you a better understanding, because everything boils down to these accounts, I've decided to just quickly bring this up. So just bear with me. Here you have this. Then you have the 1, and then you have the 2. This is for code execution, the code, and then this is for the data. All right. Then we have this is, of course, Solana. Then you have here Azos Ethereum, which just have the 1, the code, and then maybe inside as well the 2, the data. So when you look at the way these two are structured, you see that it's easier to swap this code without touching this contract, because it's 2 accounts on its own. But here it's so difficult because everything is here, and it's just, and so makes it a bit difficult. So I believe this surely give you a more virtual analysis of how those 2 accounts work, and that's what determines a lot of other things you see here. So like data type, now this uses 64-bit integer, which we will still learn about. Just keep that in mind. A lot of these things we're still going to learn, some of them one by one, but it's good you have a summary overview of the main difference of what you are dealing with. So when you talk about, you have things like uint, 64, I said 64, like the max. But over here you have the same uint or integer for up to like 256. So that's what this is saying, that in terms of this, okay, byte address, you can see this take 256 byte integer. So which means if you are writing your smart contract code, you want to refer to int or uint, you had better use uint maximum of 64 here. And currently the max here is 256. So if you are on vanilla Solidity contract, you are cool to use this. In fact, I think you can also just use uint or int and then to pick this, except you want something lower, you specify 64, 32, 8 and things like that. So but here you can use 64, 32, 8, below 64. Why? Because the way Solana account and blockchain was built, this is like the max on which it run on. So if you give it 256, it's not that it cannot do or it can't run it. It will run it, but it will need to break it into 2 or into 3, like divide it 64, 256 divided by 64. So instead of this being one transaction, this will likely end up creating about 4 or 5 transactions. I don't know the math actually. So this, I know this should create minimum of 5 transactions if you divide 256 by 64, so or more. That means you'll be paying 5 times more for the transaction, whereas you just pay 1 here. But if you have done 64, then you just pay for 1 transaction. We still learn more about data type and things like that. So when you talk about the runtime, requires Solana 1.8.1 above, then this varies depending on the network version and things like that. Then we have the function selector known as the discriminator and are 8 bytes wide. But on Ethereum, Solidity for Ethereum is 4 bytes wide. Always keep this in mind. It is their accounts that determine every other thing you see here. Every other thing is the way the account is structured to handle smart contracts that determine. Okay, I forgot to put it here. Or let's say EVM. Yeah. That isn't too fancy, but just take it like that anyway. Now, when you look at this, now from that, it affects a lot of things. So, the same when you talk about the address, is like 32-bit, but the address on Ethereum is, that's why Ethereum, the X address is about 40 long, but I think this is maybe more or something. And there are formats in which it's written, and we'll still learn more about them. Anyway, so return then we are on the built-in. There are different built-in like program ID, that's transaction to locate the program ID, or accounts involved. Remember, this deals with accounts, but these are built in like gas left, gas limit, thanks gas price and things like that. So which are not like natively working with Solana. So that when you are developing, you are using Solang Solidity, you will know what to substitute for what, especially when you are trying to modify an existing Ethereum native or vanilla Solidity into Solang Solidity. Now, contract creation, specify data account address that will be initialized, and this simply uses the new keyword. Then we have the compute budget. This, when you are dealing with Solang Solidity, you don't need to specify it, because Solana that you are dealing with handles these things based on compute units, which are like almost fixed. I think 200,000 units max or something per transaction or something. So compared to Ethereum, where you will need to pay more to actually get in the row higher seat, like I've explained it previously. So then there are some incompatibility as well, like message.sender, it recover function, try and cache statement, things like that are not, and YUL built-ins are not available. YUL is like a low-level language to Solidity used on AVM. So it's not really available like that on Solana. So, but Solidity for Solana support message sender, AC recover, try and cache, and a lot other things like that. So you can use them right here, and you know what to substitute for. Then value transfer, when you are transferring Ethereum from one account, one smart contract to the other, you need to make that address payable. That's not applicable. Automatically you can just send so or whatever, so from one smart contract called program on Solana to another. So error handling, error definition and revert with error message are not yet working. So when you have a smart contract and you're like, okay, check if is 2 equals to 1 plus 1, which is true. If not true, say the address is not right or things like that, you understand? So that is not right, but those are the things you will see in terms of Ethereum, or let's say vanilla Solidity for EVM. So this works with them, you get, but probably in future, for now you may use revert, use all those things, but you won't be able to add that second argument, which is to give what actually go wrong. You just get your normal we'll still see it when we are into the codes, practical 1. Now ERC20 compatibility, not compatible but fully compatible, and then this uses SPL token program instead, which is what we are dealing with in this course. We are going to analyze it. The special annotations like at program ID, space, seed, payer, but nothing like special at things like that. So those are the things. Do the exercise, get stuck, need. But I want to encourage you to keep, and you can always come back to this table. It's so important because when you are developing or modifying existing, knowing these things will help you to easily identify bugs in your modified vanilla Solidity code to Solang Solidity code. So important. Some of them, by the time you're watching, may not more be applicable, but just stick to that. And in the next lesson, we'll be able to start setting up and doing practical of all these things. So that is it. I remain Solomon Foske. See you in the next lesson. Keep the programming spirit and alive. Your only assurance for success. Bye for now.